Question number 34. Very important question. Which of the following statement is always true? Always true. Always. Remember that. In an elementary reaction, the rate can be increased by increasing temperature. So this is no point, right? This should be correct because either it is exothermic, endothermic, elementary, or more or less in some cases. Anyway, in all cases, you increase the temperature, the rate is normally increasing. Okay. The rate can be increased by removing the products from the reaction medium. So when you remove the product from the reaction medium, the rate is increasing. So think about the example that we discussed here. The pressure effect. Okay. So let's say this is an elementary reaction. Okay. So when you remove this one, there is no effect. Why? The pressure relationship is not attained here. If you remove this one, what is actually happen? What should actually happen? You have to think about the equilibrium. When you remove this one, when the concentration drops, it goes towards the forward reaction and equilibrium is shifting, and then the rate is increasing. There is no problem in that. Okay. Now come to this reaction where we had the rate expression given, CO. Where was it? This one, no, this one, no. See, think about this one. Now here we remove this COO, either add those, we don't care because for the rate expression, it does not affect. So the rate is not going to change. Okay. So think about this one and the other question that we discussed. Okay. Now we will come to our question. The rate can be increased by removing. Now here they are talking about the product side, not the reactant. Okay. So when you change the concentration of the reactant according to the rate law expression, the rate can be changed. Okay. Here they are talking about the product. So there are some reaction. For an example, the reversible reaction. If there is a reversible elementary reaction like this, you remove this one, then the forward reaction will increase. So the rate increases. But this is not always happening. Always that is not true. For this type of reaction, it could not be. Okay, so this is not always true. We need to find always. The rate of the reaction depends on the rate of the slowest step. This is always true because it should be the slowest step. The rate of the reaction can be increased by making delta G more negative. So delta G is like this. So you have, let's say, this type of a reaction where delta G is negative. Okay, so this is negative. Okay, so there can be another reaction with the same activation energy and the delta G is positive. Okay, so the rate depends upon this activation energy. So the activation energy here and the activation energy here is same. Either delta G is negative or delta G is positive. So there delta G cannot change the activation energy here. So it does not change the rate of the reaction all the time. So this is also wrong. So AC is correct. That is why the answer is 5. In fact, you can automatically get that answer, even though you don't know about B and D, because when A and C correct, it's always 5. Okay, so this is the explanation for this particular question.